So today we're going to go over solving and graphing absolute value inequalities. So just like we solved the absolute value equation by isolating our absolute value, we're going to do the same thing. So I'd subtract 15 from either side, and I'd have the absolute value of 4 minus x is greater than 6. We're going to do the same thing. So we isolate the absolute value. Now, instead of writing two equations, we're going to write two inequalities. So we're going to say 4 minus x is greater than 6, or 4 minus x is, and then we switch the sign, switch the inequality and switch the sign, is less than negative 6. So then we'll solve each one of these. So we subtract 4, and you get negative x is greater than 2. Subtract the 4. Negative x is less than negative 10. Then that's a negative 1 in front. So we divide by negative 1. And so we have x is less than negative 2, or x is greater than 10. So then we graph this on a number line. So so we'll start at 0. So that's negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now when we go to graph this, we're at negative 2. Since it's not equal to, it's going to be an open dot. So that's negative 2. And it says x is less than. Less than is to the left. And then you go to 10, positive 10. Again, open dot because it's not equal to. It says x is greater than that. So you go this way. If you go to number 2, draw the line. Okay, so we need to get the absolute value by itself. So we'd add 10, add 10. So we get the absolute value of x plus 4 is less than or equal to 8. And then we'd write our two inequalities from there. So x plus 4 is less than or equal to 8, or x plus 4. Again, we switch inequalities greater than or equal to negative 8. And then we solve each one of these. So subtract 4. X is less than or equal to 4. Subtract 4 here. X is greater than or equal to negative 12. So then we graph that. And since these are evens, I could count by 2s. So we'll go here. So this is 0, 2, 4, 6, 8, 10, 12. Negative 12, 2, 4. That's positive 4. Okay, now since it's equal to, these are closed dots. So equal to, and then it says x is less than or equal to that. So it goes down that way. X is greater than or equal to 12. So again, closed dot. Greater than is to the right. So what it's saying is any solution between these 2 points will work. If we looked at the other one on number 1, we're saying any numbers, any solution outside of those ones would work. So now we'll go look at 2 special cases. So if I come through here and I subtract 12 from either side, the absolute value of x plus 1 is less than negative 10. So if I look at this, okay, and I say, okay, what will work? Well, hopefully you look and see I got my absolute value and then a negative on the other side, okay? So can you have an absolute value that's less than a negative? In this case, no, you can't, so it'd be no solution, and you're done. So if you look at it, isolate the absolute value, and you answer the question like it can't be possible, then there'd be no solution. If I come over here, draw my line, add 1, 2x minus 4, and I get negative 9. Then I divide by 3, and that should be greater than. Divide by 3. So then the absolute value of 2x minus 4 is greater than negative 3. Okay, is it possible to have absolute value that's greater than negative 3? And the answer would be yes. In fact, any number, any absolute value would be greater than negative. So this would be all real numbers. So we're going through, we're setting it up similar to what we did for the equation. We just got to pay attention to the inequality, and then we'll do our number line. If you get a negative, if it's less than a negative, it's no solution. If it's greater than a negative, then it's all real numbers.